Hey developers, I hope you are doing well. I'm excited to guide you through 10 essential patterns that will shape the way you architect your microservices. Before starting, did you watch my previous video in which I talked about creating the ERD and DFD with the help of ChatGPT, Mermaid and Dot.io? If you are new here, I am Hassan and I upload tutorials on this channel. If you might be interested in watching those videos, consider subscribing to the channel. If you have any questions, comment down in this video. Let's start today's video without any further delay. Design patterns are crucial elements in the toolkit of software developers. They represent proven solutions to recurring design problems, providing a shared language and set of best practices for creating efficient, maintainable, and scalable software architectures. These patterns encapsulate years of collective industry experience and knowledge, offering developers a roadmap for addressing common challenges in a structured and effective manner. Software design patterns are general reusable solutions to common problems that arise during software development. They represent best practices and provide a structured way to solve issues without starting from scratch. Utilizing design patterns promotes code organization, readability, and the creation of robust systems. Before we jump into the exciting stuff, let's quickly revisit the core concept of microservices. It's about breaking down a monolithic application into smaller, independent services that communicate with each other. This architectural pattern brings flexibility, scalability, and maintainability to your projects. First of all, we are going to talk about Singleton pattern. The Singleton pattern addresses the need for a class to have only one instance while providing a global point of access to that instance. In the provided TypeScript code, the class Singleton is designed to achieve this Singleton behavior. The private static variable instance ensures there is only one instance of this Singleton class. The private constructor restricts direction instantiation of the class from external sources. The getInstance method serves as the entry point for obtaining the single instance, ensuring that it's created only if it does not already exist. This pattern is valuable in scenarios where a single point of control or coordination is essential, such as managing configuration settings or database connections. Moving on to the prototype pattern, it addresses the creation of new objects by copying an existing object, known as the prototype. This pattern is beneficial when creating instances of a class is more expensive or complex than copying an existing instance. In the provided JavaScript code, a prototype object named zombie is created with properties and methods. The object.createZombie statement is then employed to generate a new object, new zombie, based on the existing prototype. This mechanism enables the creation of objects with shared functionalities while allowing customization of specific properties for each instance. Now let's explore the builder pattern, which facilitates the construction of complex objects step by step. In the JavaScript example, the sandwich builder class is introduced. This class includes methods such as add bread, add meat, and add cheese, allowing the construction of a sandwich with various components. The builder pattern is particularly useful when dealing with the objects that require intricate setup processes or configurations. It enhances the code readability and maintainability by providing a clear and fluent interface for constructing objects. Moving forward, the factory pattern offers an alternative to using the new keyword for object instantiation. Instead of creating objects directly, a factory method or function is employed to handle the object creation process. In the provided JavaScript code, the scenario involves building a cross-platform app that runs on both iOS and Android. The button factory function is introduced to determine which button object to instantiate based on the platform. This pattern promotes flexibility and encapsulation, allowing for easier modification and extension of object creation logic. Now let's discuss the facade pattern, which provides a simplified interface to a set of interfaces within a subsystem. The primary goal is to present a unified and user-friendly entry point, concealing the complexities of the subsystem. In the example, classes for the plumbing and electrical systems are abstracted behind a home facade class. The facade class simplifies the operation for end users, combining intricate details of subsystems into a single, easy-to-use method. Facades are valuable for promoting code modularity, reducing dependencies, and enhancing the overall readability of complex systems. Now let's delve into the proxy pattern. This pattern involves creating a surrogate or placeholder for another object to control access to it. The proxy serves as an intermediary, allowing additional functionality to be implemented when accessing the original object. In the JavaScript example, a reactive proxy is introduced to showcase the concept. Proxies are commonly used for scenarios like lazy loading, access control, or performance optimization. In the context of frameworks like Vue.js, proxies plays a pivotal role in implementing reactivity systems, intercepting changes to data, and updating the UI accordingly. In this example, the reactive proxy intercepts access and modifications, allowing for additional behavior. Moving on to the iterator pattern, this pattern involves providing a way to access elements of an aggregate object sequentially without exposing its underlying representation. Modern languages often provide abstraction for iteration, such as for loop in JavaScript. However, in the absence of a built-in range function, custom iterators can be implemented as demonstrated in the provided JavaScript code. In this example, the range iterator class provides a custom iterator for a range of numbers, allowing for iteration with for loop. Let's explore the observer pattern. This pattern establishes a one-to-many dependency between objects so that when one object changes its state, all its dependents are notified and updated automatically. In the context of JavaScript, the RxJS library simplifies the implementation of the observer pattern using subjects. In this example, the data subject extends RxJS subject class, allowing observers to subscribe and receive updates when the data changes. Now let's discuss the mediator pattern. This pattern defines an object that centralizes communication between a set of objects, promoting loose coupling between them. The mediator acts as an intermediary, coordinating interactions and facilitating the communication without direct object references. In this example, the mediator class facilitates communication between airplane and runway objects, allowing airplanes to request landing without direct interactions. Finally, let's explore the state pattern. This pattern allows an object to alter its behavior when its internal state changes. This example demonstrates a simplified implementation in JavaScript where a human class exhibits different behaviors based on its mood state. In this example, the human class encapsulates different states, happy state and angry state, allowing dynamic switching between behaviors. In wrapping our exploration of these software tricks, think of them as spatial tools that help computer builders, each with its own job. The Singleton tool ensures there is only one of something, like a spatial toy. The state tool lets things act differently based on how they feel inside, whether happy or grumpy. The builder tool helps build complicated things step by step, like putting together a favorite sandwich. The factory tool is like a helper that decides which button to press for different devices, and the facade tool makes tricky things easier by combining them into one simple thing to use. The proxy tool acts like a superhero guard, watching and controlling what goes in and out, and the iterator tool helps count and list things easily. With the observer tool, different things can talk to each other and know what's going on, while the mediator tool is like a middle person helping objects communicate. Finally, the state tool, when it shows up again, is about changing behaviors like magic. So these tools are like friends of for computer builders, making everything more fun and exciting as they embark on their computer adventures. If you have any questions or if there is anything else you'd like to discuss, feel free to let me know. If you like this video, click the subscribe button and don't forget to click the bell icon so you will be notified when I publish the next video. Thank you guys for watching.